Hey guys, in this video we will be looking at more practice problems of trigonometric identities. So our first question here is verify the equation using 60 degrees. And here's our equation. Secant of theta is equal to tan of theta over sine of theta. So first what we're going to do is we are actually going to plug in 60 degrees into theta. So we will have secant 60 degrees equals tan of 60 degrees and sine of 60 degrees. Now we should draw 60 degrees in the Cartesian plane. So we draw a line like that, and this should be about 60 degrees. And if we come down like that, this will be the right angle. And since this is 60 degrees, this side will be 30 degrees. Now guys, if we look at this triangle, it is a special triangle because there's a 60 degrees and a 30 degree angle. So the 60 degree angle side will be root 3 because this side is facing 60 degrees, and the side facing 30 degrees will be equal to 1, and our hypotenuse will be 2. So guys, now what is the value of secant of 60 degrees? Secant of 60 degrees is, well, secant of 60 degrees will be x over r. Wait, one is going to be our x, this is going to be our y, and this is going to be our r. So secant of 60 degrees is going to be r over x, and tan of 60 degrees is going to be y over x, and sine of 60 degrees is going to be y over r. So now guys, we just need to plug in our values. So what's our x value? Our x value is 1, our r value is 2, 2 goes here, y is root 3, x is 1, and y is root 3. So now if we move this here, that will be 2 is equal to root 3 over 2 root 3, which is going to be 2 equals, roots cancel out, to be 2 equals to 2, and left side is equal to right side. So therefore, we verified the equation using 60 degrees. So just to review, we have two special triangles. So let's draw two triangles like that. So first, if this is 60 degrees and if we have 30 degrees, so if we have 60 and 30 degrees in a right triangle, the side facing, say, the 60 degrees will be root 3, the side that's facing the 30 degrees will be 1, and the hypotenuse will always be 2. Alright, now what if we have two 45 degrees in a right triangle? Well, the two sides facing the 45 degree angles will all both be 1 and 1, and our hypotenuse will be root 2. So for these verifying equation questions, we plug in the degree, the specific degree, into the equation, and we can either use this special triangle or this special triangle to prove that the equation is true. Alright guys, here's our next question. Prove that secant of theta is equal to tan of theta over sine of theta. So basically guys, we have to change the identities so that the right side, the left side is equals the right side. So how should we start? I think we should start by changing the tan of theta. So let's write secant of theta is equal to sine of theta. And what's tan of theta, guys? Tan of theta can become sine of theta over cos of theta. Now we can say that secant of theta is basically equal to sine of theta over cos of theta multiplied, oh no, sorry guys, divided by sine of theta over 1, right guys? Because this means division. Now if we scroll down, secant of theta, that means will equal sine of theta over cos of theta multiplied by sine, oh sorry guys, multiplied by 1 over sine of theta, and the two signs will cancel out, so that means that secant of theta will equal 1 over cos of theta. But what's cos of theta, guys? Cos of theta, 1 over cos of theta, sorry, is equal to secant of theta. So left side is equal to right side, so therefore we can say that we just proved that secant of data is equal to tan of data over sine of data. Alright guys, so here's our last question. We have to determine the non-permissible values in radians of the variable in the expression below, which is this. Okay guys, so the first step is to change everything into sine or cosine. So let's do that. That is going to equal cotangent of data will equal 1 over tan of data. Oh, sorry guys. Cotangent of data will equal cos of data over sine of data, and cosecant of data will equal 1 over sine of data, and cosine of data is just cosine of data. And if we lower it here, this will become that over cos of data over sine of data. So that means that our sine of data and cos of data is below the fraction lines. So we can say that our sine of data cannot equal 0 and our cos of data cannot equal 0. Now, let's draw the sine and cosine graphs to see which values of data cannot equal 0. So we draw sine graph like that, and this is going to be our cosine graph. My sine graph starts here, guys, and it goes like, it goes like that. So this will be 0, this will be pi over 2, this will be pi, this will be 3 pi over 2, and this will be 2 pi. And our cosine function will start here and go like that. This will be 0, this will be pi over 2, this will be pi, this will be 3 pi over 2, and this will be 2 pi right here, guys. So now, what can data not equal? Well, sine of data equals 0 when it's at 0, pi, and 2 pi. So that means that our data cannot equal 0, pi, 2 pi, and so on. How about our cosine graph here? Cosine of data. Cosine of data equals 0 at pi over 2 and 3 pi over 2. So our data cannot equal pi over 2, 3 pi over 2, and so on. Now, how do we write a general solution for these two guys? Well, for this guy, we can say that our data cannot equal n pi, where n is part of the integer system. And for this guy, we can say that pi over 2 plus n pi, where n is part of the integer system. Alright guys, there's one more problem. We need to simplify this expression right here. So let's first, how about we change all of them into sine or cosine? So cotangent of data will equal cos of data over sine of data. And this is going to, cosecant of data is going to be 1 over sine of data multiplied by cos of data. And this is going to be cos of data over sine of data all over cos of data over sine of data. Now, this is basically cos of data over sine of data divided by cos of data, like right here, divided by cos of data over sine of data, and this will be common multiplication like that. So we can cross multiply, we can cross these guys out, we can cross these guys out to become 1, 1, 1, 1, which, and our simplified version of that expression is going to be 1.